Good afternoon, guys. Let's wait another minute to give everybody time to join. Let's get started. Welcome to the AI and ML Learning Bootcamp. My name is Edgar Murillo. I'm a senior AI solution architect, and I'll be the instructor for this bootcamp. This is the agenda for today. First, we're going to have a little bit of introductions. I'm going to provide some information about my background. You will have the opportunity to introduce yourself as well. Later, we're going to talk about a brief history of AI and then the different types of artificial intelligence. Another topic that we're going to discuss is the typical problems that you can solve with machine learning and what are the common learning algorithms. And finally, we're going to close with a description of the machine learning process. So let's get to it. I'm afraid I'm going to date myself, but that's okay. I've been working in IT for more than 40 years. I actually wrote my first line of code when I was 17 on a computer just like this one. This is the digital PDP 11. This is way, way, way before PCs existed. So you can imagine how long ago. This computer had two drives. Had a fixed disk, was 5 megabytes, and it had a removable disk that was another 5 megabytes, which at the time was huge storage. Right now, even I don't know a single picture, even not even high resolution, it's more than 5 megabytes. But that's what we used to work with in those days. I moved into networking in the late 80s, and then I became a certified instructor in the mid 90s. By the time NetWare or Novell was the king of network operating systems, so my first certification was on Novell NetWare. That was back in '94, and then Microsoft started moving into that field, and I started also taking the training and the certifications, and I became a trainer, a Microsoft trainer after that. One thing that you're going to notice is who actually signed the certificate, Mr. Bill Gates. So that's funny. Well, anyways, so after that, I moved into Cisco. I joined Cisco in 1998, where I continued learning about networking, obviously. And I had the opportunity to travel the world teaching about Cisco technologies. My role was in technical marketing, so I was a technical marketing engineer. Then I became a technical marketing manager. So I had the opportunity to go and teach our own engineers, teach customers, teach even trainers that would train on Cisco products. So that was a fun time as well. So I was doing that for many years, several years, until Cisco made a move that actually changed my career, completely changed my career. So what happened is that Cisco decided to become a software company, a major change in the company, because most of us were more kind of a hardware people, and that change to software was not easy. However, in my case, remember that I started my career developing code. That change was not that complicated. So what I actually did is I learned Python, and then I realized that I can use Python to automate some of the network operations that we were doing that were very time consuming. And I said to my colleagues, you know what, guys, if you learn this language, you will find a lot of libraries that can help you to do things much, much faster. And that's how I started into automation. After that, in 2016, the company started saying that data science would become the next big thing. I remember my manager recommended to take data science courses, so I did. I enrolled in on online courses. I think it was Coursera, other companies at the time, and I started learning about data science and artificial intelligence and machine learning. And soon after that, Cisco started a program with North Carolina State University. a data science certification, similar to this one, actually. Probably a bit longer. It took me about a year and a half to complete it, that certification. And like I said, after almost 2 years, I became a data science practitioner. I don't call myself a data scientist because in reality that takes more learning, more time. It requires at least, I don't know, master degrees, or most of the data science I work with actually have PhDs. So what I'm calling myself, besides being a solution architect, is a data science practitioner. So I know how to use data science. I know how to use AI, ML to solve business problems. And that's what I'm hoping to share with you, that knowledge and that experience. Since then, what I've been doing is designing and developing and deploying ML-based solutions to solve business problems. First, starting with Cisco, and then later with HPE, also known as Hewlett Packard Enterprise. And this is something that I want to emphasize, right? The part that says solve business problems. Remember this: every technology exists to solve a business problem. We have to keep that in mind. One of the first things that we have to do with anything we do in this AI is not no different, is the driver of all this is the business problem they want to solve. We're not going to use technology just for the sake of technology. It's meant to make something more efficient, to improve the revenue, to improve the bottom line. At the end, it needs to benefit the business or humanity in general, not just a business. But that's the whole idea behind this. Don't forget that. As part of my background, I also have an MBA, which helps because it makes me focus on that part of it. AI is not the solution to everything. It helps in certain things, and it's just another tool. Don't forget that. AI is just another tool that you have in your toolkit to make the company that you work for more successful. Well, AI is changing the world. It's changing our lives. And in 2023, not long ago, I decided to leave the corporate world and focus on training the next generation of AI professionals. And that's why I'm basically here. I think you guys are the future of AI. You have a very bright future ahead of you in this field. And this is just the starting point. There are many things to come with the new AI technologies like generative AI and large language models that, like I said, they're going to change completely the way that we work. Enough about me. Now it's your turn. Please share your name. From where are you joining us? What is your current job, briefly? And why are you taking this boot camp? What do you want to get out of it? Also, let's try to be brief because I know that there are many people here in the call. So I just want to make sure that everybody has the opportunity to introduce themselves. Excellent. Thank you all. So now let's move to the next topic, which is a brief history of AI and ML. So one of the things that I want to make sure that you understand is that AI is not a new concept. It's been there for a while. Well, some people actually say that the first intelligent machine was a mechanical calculator that Pascal invented in 1642. That might be going too far, but one thing that is for sure is that in the 1950s is when we start talking about AI, artificial intelligence, and machine learning. In this case, Alan Turing he published a paper that was entitled "Computing Machinery Intelligence," and Turing is considered the father of computer science. So he is one of the pioneers of computing in general. Later, John McCarthy, he actually came up with the term artificial intelligence in 1955. You're going to see on the web that sometimes says 1955, sometimes says 1956. Well, it seems like the term was coined in 1955, but there was a conference on artificial intelligence in 1956. So that's why you see the both dates. But anyway, it's the same in the same decade, right? Here you see the timeline of artificial intelligence, right? It's a long timeline, different events at different points in time. What is important to note is that it wasn't always that successful. It had ups and downs. At the beginning was a novelty, and then they were not able to see the benefits. Funding stopped, and we had what they called the first winter of AI. Then again, I got a kind of a resurgence about in the 80s. Same situation. They were not seeing all the expected benefits, and had a second winter of AI. And then in the 2000s, we start seeing kind of AI going again in the right direction, right? It was becoming more useful, more popular, and we will talk about why in a moment. As I mentioned earlier, AI had ups and downs. It was a kind of a roller coaster ride. But the question is, what is exactly AI? How do you define it? And the definition has evolved over time. So if you Google it, you will find many different definitions. I chose this one. This is the one that I like a little bit more because it has a different component that talks about the ability of performing cognitive functions similar to human minds. So I think that's one of the key benefits or the key characteristics of artificial intelligence. And the part that I actually like the most is at the end when it says, even exercising creativity, because that's what generative AI is bringing to the picture. It's something that we haven't seen before. It was able to do many intelligent things like winning games, chess games, Go games, and things like that. But it was not able to create new things. So now with the latest advances in generative AI, we're able to create text, images, video, music, even code with this new technology. So now that's part of AI in general. And that's very, very powerful. All right. So any questions or comments so far? Perfect. So let's talk about the different types of AI. Okay. So let's imagine that artificial intelligence is like a tree with many different branches, some branches longer than others. And how many branches do we have on an artificial intelligence tree? Well, that depends on who you ask. Some people say three, five, seven, even more. In the interest of time and simplicity, let's talk about the top three or the most well known branches of AI. On one hand, you have artificial narrow intelligence. Then you also have artificial general intelligence, artificial superintelligence, right? So the reality is that most of the advances we are seeing in AI lately, or in general, is on narrow intelligence. Okay, superintelligence is still kind of a science fiction thing. Is not there yet. And we're going to see that artificial general intelligence is still work in progress, but is not something that it's in the really near term or short term. So keep in mind, make sure that you understand that point, that when we're talking about AI right now and all that is happening with AI, we are talking about just the narrow intelligence portion or branch of AI, not the other ones. Okay. Let's dig a little bit deeper on each one of the branches. We're going to start with artificial superintelligence, and you can read a little bit more about the definition. I think that the main point here is, like I said before, this is basically science fiction still. So when you see the movie I, Robot or any other movie that has any human killing robots, we are still talking about artificial superintelligence. And basically, what it means is that it's smarter than humans, right? Right now, we know that people are saying that what we have is smarter than humans. It depends on how you see it and how you define intelligence. It for sure, computers can perform operations faster and have more memory, but that doesn't make it necessarily smarter than humans, right? So the point is, artificial superintelligence is not something that is practical or right now exists. Okay? The next one is called artificial general intelligence. And if you ask scientists about this, they would say, in the past, let's say 5 years ago, even less than 5 years ago, they would say that this is something that would happen in 50 to 100 years, where you have an intelligence that is similar to human in many different ways at the same time, right? Now they're saying, well, maybe it's not 50 years from now, but it's in 10 perhaps. The point is that, again, this is still work in progress. It's not completely there yet. When we have the, let's say, the fusion of supercomputers, quantum computers, and all the generative AI technologies like OpenAI's GPT and other large language models, we might see some advances in general artificial intelligence. But right now, most of the work, like I said before, is on narrow intelligence. Things that can do one thing, right? Tools that can do one thing very well and better than humans, but they can do it one at a time. They're not able to do all the different tasks simultaneously. So this is very important. Sometimes we generalize AI and we talk about doomsday, or we talk about certain tools, but in reality, the AI that we are making advances on, we're making progress, is just a narrow intelligence AI. Tools that are very good to do very specific things. In the definition, you're going to see things that are very familiar, right? Machine learning, neural network algorithms, language processing, image recognition, self-driving cars, virtual assistants. So all those things that we have today are basically artificial narrow intelligence. You may have noticed that this is the first time we're talking about machine learning, and we will explain a little bit more what actually machine learning is and what is the difference with AI. So let's move to the next topic then, which is narrow AI, or let's just call it AI, and machine learning, artificial neural networks, and deep learning. So basically, machine learning is just a subset of artificial intelligence. Just want to remind you that from now on, when I talk about artificial intelligence, I'm talking about artificial narrow intelligence, okay? But let's generalize it and call it AI, but it's just narrow. So, like I said, machine learning is a subset of AI. So, this means that we can have AI without ML. That's possible. And that's how it used to be for a long time. So, basically, what one of the type of AIs that doesn't use ML is expert systems that were programmed with very specific rules created by experts on the subject matter to make decisions and perform tasks, even to answer questions based on knowledge databases. So those computers were programmed to do the task. So because of that, they were not using machine learning because they were actually not learning anything. They were just executing code created by programmers with instructions or guidance from experts. Artificial neural networks are algorithms inspired on human neural connections. And notice that I'm making an emphasis on inspired, okay? So, in reality, they have little to do with how the brain works, but the concept was taken from neural networks. Okay, so it's very important to notice that it's just inspired, right? It's not necessarily meaning that actually simulates how the brain works. So, what is really ML? Well, one thing that might surprise you is that ML is not new. It was defined by Arthur Samuel in 1959. And you can read the definition. It's a field of study that gives computers the ability to learn without being explicitly programmed. And that's very interesting. Ability to learn without being explicitly programmed. So remember in the past AI, you actually had to program the rules to make the computer do things or make it more intelligent. In this case, you're not programming the computer to do what you're asking to do. You're teaching the computer, and that's the main difference. This completely revolutionized AI, right? But the question is, this was created in 1959. Why it took almost 50 years to become so popular? And there's a very simple reason for that. The machine learning algorithms, they require a lot of data, huge amounts of data, and very powerful computers to actually be really useful. To learn from the data, to predict, to make inferences, they're really accurate, right? And we didn't have that at the time. So what happened is that we got the internet, we got social media. Many companies are doing their digital transformation, so they are changing, transforming their documents, their processes into a digital format. And all this data now can be fed into these machine learning algorithms. On the other hand, we have companies like Intel, Nvidia, and all the cloud service providers that offer this computational power and storage as a service, making it very accessible to companies of all sizes. So combine all the data that we have now available on the web, plus very powerful processors, plus companies that offer this compute and storage systems in a very easy way to consume in order to develop this AI applications or the AI tools. That's why we're seeing this explosion now. So I think it's time for a recap. So far, we've talked about a brief history of AI. It's nothing new. It's been there for a while, had ups and downs, and now it's becoming obviously more popular and widely used in many, many different sectors. We also talk about the different types of AI. People tend to talk about AI as kind of like one thing, but we learn that there are different branches of AI. And the one that we work mostly is just one of the branches. We also talk about how machine learning integrates into AI, which is just one part of AI. And also discuss different algorithms that are used lately, like artificial neural networks and deep learning. We will discuss those on more detail on other sessions. I'm going to go really deep on each one of them. But for now, I think that's a good introduction and a perfect time to do a quiz. At this point of the training, what I normally do is use one of those online quiz tools. I've used Kahoot in the past, where you can get the student engaged and start asking questions. You can do it like a kind of a trivia fashion where they have timing and there's the people that respond faster. They go on top of the leaderboard, things like that. You can even incentivize them with some kind of prize or any other way that they get noticed about it. These are the questions that I would typically ask at this point. And the idea of this is to make it more interactive, right? I always mention that they can interrupt me at any time if they have any question, but it's good to do these checkpoints along the way. So I hope you enjoy the training, the presentation, and hope to talk to you soon. Bye now.